All right, let's keep going. So we just pack and go our file, and now we're going to create a new drawing file. We've made parts, we've made assemblies. Welcome to the exciting world of drawings now. We are going to select our sheet template. Now, what I have already done before this video is go to the Blackboard, and I've downloaded this project to sheet format. Now I found that in K2Cam assignments, and then from there I browsed to the project 2 pulley drawing set prototype. Now yours is never going to look quite as detailed as mine here typically, but you should be able to see the brief. Definitely read that before you go too much further. And I want you to download the project 2 sheet format just by clicking on it. Excuse me, a little hiccup there. So I've downloaded that into that job folder already. I'm going to browse for that folder. It's going to be on my desktop. From the desktop, I want to find that K2Cam semester 2017 folders. Assignment 2. Grab that template and open it. And we can see it's populated with this little RMIT drawing template. So let's hit OK and keep cracking with that. Excellent. So here is our brand new drawing page, and you'll notice it's automatically open this little model view insertion tool here. If we're in view layout, we could also get to this same window by clicking the model view button up the top there. And what I'm going to do is browse for my general assembly and start dropping that in there. So let's grab our general assembly to start with. Say open. And you can see I can now choose the view I'm after. At the moment it's a funny shape. See how it's quite wide and rectangular when we know the pulley isn't wide, it's tall. That is because this is currently in the exploded state we made earlier. So if I untick that exploded state box and just sort of tell this to think again, we can see now it's much more pulley shaped. So I'm going to start dropping this in. That looks like a nice sort of front view there. I might go for more of a side view to begin with, something like that. I can click to place a drawing. And if I just drag my mouse out after already having clicked once to drop that, I can then click once again to drop a new view at that angle. I could drag up to the top, I can drop a new view at that angle, and I can drag out to the side and I can drop a new view at that angle. So I'm going to drag this round to, somewhere it all sort of looks nice and square. I think this sheet scale is a bit small. If I want to up that a little bit, look right down the bottom corner here at sheet 1. I right click that and I say properties. And I can change that to something a little bigger, or maybe 1 to 3. I think something like 1 to 2 could just be a bit big and pushing it. That didn't really seem to update. It is set to the sheet scale. I can click rebuild if I think that that's not doing what I'm telling it. And I can double check that my properties did save what I set them to. That just might be an indicator we can go a little bit bigger. Let's try 1 to 2. Yeah, it looks pretty good. I reckon we're going to get away with that. Now, the next thing I want to insert is an exploded view. So I can insert my views from here. We can see GA01 is already there, but we have more options than that. What I'm going to use this time is the view palette. So I'll expand that out from the side. In a similar way, I have to browse for the part that I want to insert into the drawing. I'll open that general assembly. And this is my preferred way because what it will give me is this palette here to choose from. And all I'm going to get is the isometric exploded view and drop that there. Now this exploded view was created in an earlier video. The exploded view itself is embedded in the assembly file. If you want an exploded view of an assembly in a drawing, you're going to have to make that exploded view in the assembly itself. We did a video on that earlier. You might want to go grab that to refresh if you're not sure what I'm on about there. Alright, so here we've got a lot of views, and we've got probably more than enough views for the first page of our drawing document. Your drawings, they're like a book. They've got to tell a story of the parts you want to make, and you don't necessarily need to tell that whole story in your introduction. This first page is like an introduction. It's that the manufacturer can open this up and they can start to get an overview. They can understand where the assembly of this is going. And then as they turn through the pages, they get more and more detail. So, your first page here is a general assembly. Your second page would then probably be this sub-assembly. And then after that, you'd have the drawings for each part. You're not going to need to do a drawing for any part that is hardware or OEM, such as the screws, bolts, or the split pin, which you'll add later, and that's all going to make a bit of sense if you've been coming to the classes. Very good. So let's add some view labels to all of this. Now, I think... Look, we might get away with these 4 views here. I'm worried they're actually going to be a bit too big and we won't have space to put in everything we're going to put in. So yeah, let's just make them smaller now. I'm going to go to properties and I'm going to drop that sheet scale back to 1:3. I think that was probably a bit more on the money. And there are my views. Next, I'm going to come to annotation, and you see we got a lot of tools here. The one we're going to be using for now is the note, and that's just how we add text to our drawing. So I'm going to drop this text inside this magic pink box. It's just appearing as I hover near that part, and that's telling me this text will be linked to that part once I create it. The advantage of it being linked, if I just type isometric view, that's what I want to type for my view label. I could center that text, and now if I just reposition that text, I know it's already linked to the drawing because it linked when I first created it. I can place that text effectively anywhere around that part, and if I start moving that drawing, the text moves with it. That is the advantage of linking your text to the view itself. And so to keep going, I can just copy and paste that text I've already made since it's got all the settings I like, and I'll just click on a new view that I want to link my new pasted text to, and you can see as I click and drop using Control V there to paste. Oh, at some point I have accidentally copied and pasted the whole drawing. I'm just going to grab the text this time, and I'm going to drop that down here. There we go. And you'll see that each one of those bits of text is linked to the new drawing because I clicked and selected that drawing before I pasted the new text. And I'll just keep going, tidying these up. This is my... I don't want that to be bold. You silly SolidWorks. Alright, let's change isometric there to side view. We don't need to type view twice, it's a bit redundant. Let's change this one to front view. That is just the most annoying toolbar. Why does it open over what I'm trying to type on? Let's change that to front view. And let's change this to top view. Oh, not bold again. This is just, let's turn that off. Top view. That is the worst toolbar of all time. Alright. And I can just drag that round a bit. It looks like that one... Oh no, there we go. It's just a bit slow to respond. Now, I think that is a little bit small. I actually preferred this at 2:1. I can give that its own custom scale. So I'll say use custom scale, user defined, and I'll just type in 1:2, and that'll make that a little bit bigger. Now this also needs its own label, and the label that belongs on this part is isometric exploded view. Now let's wait for that terrible toolbar. Why does it do that? Does it hate me? Isometric exploded view. Alright, and we need one little bit more information on that. We want to make sure that we tell everyone the scale is different to the page scale, so let's just put scale 1:2. 2 right there. Very good. So we've inserted our drawing views, and then we've labeled our drawing views. Let's have a look at some of the other annotation on this page. We can see down the bottom here, we've got our student name and our student number. The best way to update that is using the custom properties. Now, we've looked at this a lot in class, so it shouldn't be anything new to you really, but if it is, it's our custom properties up here, and it's where we sort of put what we want our metadata for each part to be. So for example, you'll notice this drawing already knows that this is GA01 part number and it's the General Assembly. Now that is because I have that information set in the document properties on the assembly for my pulley wheel. And so SolidWorks has been able to find that metadata and pull it across to the drawing. Now, if that's all a bit confusing, feel free to talk to me about it in class. It's not really going to be critical to your marks for this semester to understand that component of SolidWorks or to even use it, but it's definitely very valuable for you to do a bit more research. So I'm in my custom properties, and I just want to change these two bits of text called student name and student number with the intention that that should automatically update this information here, as well as automatically updating it on any future pages. That's pretty cool. So for student name, let's put the old student name in there. I'll just get you to put first and last name, and then a student number. Let's make up some number, something like that. Very good. Look at that. Okay. And go. And now we can see it's automatically updated that information. All right. I'm going to save this drawing. That's definitely a very good idea. Let's have a look at, make sure we're in the right CAD folder, assignment 2. And I might just call this drawing 002. Save. Very good. All right. So we have a lot of views, but we're still missing a lot of information. So things we still need to add will be our dimensions. We need to make sure there's at least a couple of dimensions on this page. Because it's an assembly page, we don't really need that many. It's just going to be a few overall dimensions, length, width, height, that describe the finished size of the product. That's all we really need here. The other information we still need to put on there is a bill of materials, and that bill of materials will allow us to then place some little balloon callouts on this exploded view so that we know what those parts are, what they're made of, what they're called, all that kind of really valuable information. So I'm going to just start by moving everything towards the bottom of the page, so I open up a reasonable space around the top there. These views are linked, which means that I have to move them in a particular order. So you see I have to move that down first, and the rest kind of automatically follows it. And finally, I'll just get that down a bit out of the way. Very good. So I'm going to insert my bill of materials. I'll do that by right-clicking the exploded view. Really, you could right-click any view of this sub-assembly. General assembly, I should say. Then I'm going to come down to tables. Then I'm going to come to bill of materials. So we'll select that. And I'm going to hit OK, because all these settings seem pretty good. You can play around with those if you want. Just see what the effect is, and I can drop my bill of materials in here. Now this is all right. It's probably reasonable information. It's got a part number, it's got a description, but what I want to add here is also what the material and the finish of each part is. To do that, I have to make sure my parts actually have materials and finishes set. So I might just come into one part, any part. I'm going to choose the side plate there, and I'll open that. And I'm going to check what the custom properties are for this part. So I can see I've got a description, but not much else. So I'm going to add a few more fields here. I'm going to add a material. And that material, I'm just going to choose from my drop-down list here to be linked to the SolidWorks material, meaning the material that's been set here. For finish, I'll have to write that myself. That doesn't really have any automatic linking to anywhere. I might just say that this is painted black. You know, something nice and simple like that. Another one which is good for sheet metal parts is we might want to put our thickness in here. And we can actually do something pretty clever. We can look for our sheet metal feature. So I've placed my cursor just at the front of that toolbar, that little text field, and I'm going to select my sheet metal feature there. That highlights that thickness there. I can click that dimension and it should pull it automatically across into here. We can give it another click if it's just losing itself a little bit. Let's try just putting a little bit of text in there to get it started. There we go. It's a bit temperamental this morning. And now we can see that that should read 2 millimeters, and that is automatically driven by that dimension there. So that means if we start changing the thickness of this, then this property is going to automatically update, and that's very valuable to us. Finally, I'm going to put in my own little part number because at the moment that drawing is linking by default to the file name for the part number, and we don't necessarily want that. So thickness, part number, thickness at sheet metal, part number for this one is P03, and I reckon that is a pretty solid amount of custom properties. Now you can actually just copy, Control C, and then paste that into another part as well. So, you know, you don't have to really type that out every single time you want to add some properties to a part. So let's have a look at that in a bit more detail. So just say I wanted to add similar details to something like the pulley wheel. I can open that part. I've just right-clicked it and selected Open Part. And then from here, I can come to the custom properties, and because the last thing I copied were those features, I can then paste those in here. And we can see it's still linked to the old part, so let's just refresh anything we need to refresh to ensure the links are talking about the right thing. This is an acetal pulley wheel, I believe. And we want to just make sure that everything is correct, so let's put P03. Acetal's a type of nylon, so instead of finish paint black, let's just say finish deburr, meaning take off all the rough edges after you've made it in the tool. That looks alright. We'll hit OK. I'll save that. And you can see how quick that was just to copy, paste, and slightly manipulate to keep that, you know, those custom properties nicely set up on every single part. Again, that's not critical to your grades for this, that you've done that. The alternative to setting up custom properties is to, for example, on these bolts, come into the text field. You'll note the cell value is linked to a property in a read-only external mode. Do you want to break the link and override the value in the BOM? We can just say yes to that, and that will allow us to just write manually whatever we feel like. M10, what was that? I think it was actually P08. In the description, I could again overwrite the link and just manually write M10 bulb. So, you know, you've got options. That's a much easier way, but it doesn't have that same automation and that same level of depth to the data connected to your parts as making sure that's done with custom properties. So, right click, insert, column right, and you see it's created this new column. Now, all the other columns have a value. This one doesn't know what its value is yet, so let's tell it. Under property name, we're going to select material, which we've set up in 2 parts already. we can see side plate is saying material not specified. There's no points for guessing why that is. It's because we haven't specified a material for that part. So I'm going to open up the side plate and make sure there's something specified this time. So I'll right click here where it says material not specified and just set it to something like plain carbon steel for this one. I think there's even a sheet steel somewhere. No, I'm a liar. It wasn't there. Forget it. Let's just call it plain carbon steel. That's good enough for me. We can now close that, and we should see that our bill of materials has automatically updated with that new information. Now that automatic updating there is the strength of using custom properties to create this information over manually typing the information, where you'll then also have to manually update it if there's any design changes. All right, we'll add 2 more columns here. Insert column right, and then under property name we will select finish, and then we will add 1 more. Insert column right, and under this property name we will put in thickness. Should be our final one. It's right down the bottom here. Now I can only see these because I've added these custom properties to the parts. If I hadn't have created, for example, thickness as a custom property, I wouldn't have been able to select thickness from that list. It's only because one of the parts on this drawing has the custom property of thickness that I'm able to select that and create a table for it. Now I'm just going to come in, I'll right click, and I'm going to open this P07, and I'm just going to set something in the thickness. Now thickness is quite relevant to sheet metal parts. For injection molded parts it's less relevant because the thickness can actually change and undulate over the part, particularly where there's draft. So under thickness, instead of having it automatically link, actually we could still link it. Let's link it. So what I want to say is that the average wall thickness, or the nominal wall, nom for short, so nominal wall will be, now if I find the sketch, for example here, where I created my revolve feature, then that should show me what dimensions were used to create that sketch. One of those dimensions is that 5mm dimension where I set the thickness of my part. There we go. So nominal wall 5mm. That's probably pretty good for an injection molded part for thickness. I'll close that. And now we're looking pretty good. Oh, excuse me, there's a bit of a sneeze there. Alrighty, moving on. So there we have a pretty good bill of materials. I can right click, sorry, not right click, just usual click, left click, to drag that around, manipulate it, set it where I want. I'll just put it in there. Now you will have to finish filling out this whole bill of materials. If you get to a part where you think the thickness is irrelevant, for example the bushing, you might go, that just doesn't make any sense, it doesn't have a thickness, it's a bushing, get over yourself. You could just put something there like NA, meaning non-applicable. Alright, that's looking pretty good, but how do we tell people which part is which? So we've got all the information we want here, we've got all the parts drawn here, but we have to tell them which line of information relates to which part. To do that we use the balloon feature just here. There's also auto balloon, have a play around with that. It's a bit messy for my liking, so I tend to just use the normal or standard balloon tool, which allows me to place them wherever I want. And I'm just going to place balloons on these parts. Now we never balloon the same part twice, meaning where I've got two bushings, I only place a balloon on one bushing. It's up to the reader to understand from the drawing that there is two of those bushings, and that if those two parts look exactly the same, that is probably the two bushings. We don't have to label both of them. Alright, and we'll just put one label on here because we're just labeling this as subassembly 1 here. We're not doing the parts separately yet. You do these parts exploded in a new drawing view. If you want to check out what that means, have a look at the emailed round content from last week's class or yesterday's class, whenever that was, that had the example drawings. Remember, like any example document that I give you out in class, it's not intended to be a cheat sheet to get you through. You know, it's not perfect. So make sure you use your own intelligence when making yours and try and make the best set of drawings you can. I don't want you to just copy by rote what I hand out. That won't get you a very good mark. Have a go at really thinking about what you're drawing, what the information is you're putting down, and just making the clearest set of drawings possible. Alright, so what I've just done there while I was talking is grabbed a magnetic line, which is a special balloon tool, and by dragging that magnetic line through, all my balloons have snapped to it, and it just tidies up the look of that page tremendously. Now, depending on where we drop our line, will change the arrowhead. If I just pick that up and drop it on an edge instead, for example there, it'll turn into an arrow like everything else. I don't really care which one you want to use, just go with personal preference. Alright, so that's pretty good. Our bomb's in, our exploded view's in, and everything is labeled. We can count it from 1 through 7 if we want to make sure we haven't forgotten anything. So we've got 1, 2, 3, 4, 5, 6, and we're missing a balloon on the nut at the end. That's pretty easy to add in. We'll just drop it in like so. Now, if you really want to, you can drag things around in this bill of materials to change their order. You know, you could try getting that reading 1 through to 7, could be quite clean. I'll leave it up to you what you want to do there. Just going to hit save on this drawing temporarily. Alright, so finally I should start cleaning this page up a little bit and doing some finishing touches. So what it says here is what will appear as the page name when we export this as a PDF to email it to our manufacturer. So let's try and make it tidy. Instead of sheet 1, I'm going to rename that to what's on it. We will call it GA01, like so. And on top of that, I want to put a few dimensions on here. So I'm going to, under my annotation toolbar, come to Smart Dimension, and I'm just going to put a length, width, height. So first of all, I'll put the maybe the width on here. Just looking for the other side of that. Very good. I can drop that in up there. It's thinking a bit. Now I want to put my overall height. I should be able to just come from the top of my pivot pin down to the bottom of my wheel. And then, well, what I might actually do is chuck that width on that view, because I think that this is probably going to be the best view for labeling the width. And so I'll just put the width of the overall pulley in there, maybe one width of what the screw's all about, and then I can do one width of what the pulley's all about. So, you know, something like reinforcing plate to reinforcing plate. We might even want to, if we think it's useful information, place a internal dimension across there. There we go. Now let's just zoom out and have a look at our page. We've got a few hotkeys there. I'm just going to use this zoom to sheet, and that allows me to see the sheet in full. And I'll just pull out some of those dimensions while I'm there. Alright, that doesn't look too bad. Now I've got a few weird dimensions. For example, this one, 51.85, that's just a bolt, meaning that it's an off-the-shelf part, and it's probably not actually as accurate a length as that. If I want to change the tolerance, or, you know, the amount of decimal places there, I can select the dimension, and under tolerance precision, I can back that off to none, and then it will just tell me that, you know, it's approximately a 52mm bolt, and that's more than enough information. Sometimes, particularly with dimensions, too much information is just going to complicate things. The manufacturer will think that that bolt has to be exactly 51.89. It will take them a long time to actually make it that accurate. They'll have to, buff it back, and then they'll charge you for that. So, if it only has to be about 52 millimeters, then make sure that your dimension reflects that. Remember, it's about being clear and imagining what other people will infer from reading your drawings. Alright, so this isn't really a finished page. I've got to fill out this bomb still, but that's a bit tedious to watch, so we won't do that in the tutorial. We've seen two options of filling it out, one using custom properties like these parts here, and the other option of just manually overriding text in the bomb. Very good, I'm going to save this. Just before I do, the next thing you should be doing after this is repeating all these steps for your sub-assembly to create a nice assembly view of your sub-assembly 1 that shows it exploded, shows some overall dimensions, shows a bomb, everything we just did here. To do that, do not create a new drawing file. All you need to do is click this little button here which says Add Sheet, and lo and behold, it will create a new fresh sheet in your document where you can then start drawing your new sub-assembly view. For example, we could go to the View palette. We could browse for where our sub-assembly is saved. Assignment 2. SAO 1 Mark II. Open that up and drop that in. So let's have a look at the, for example, the front plane there. And we could get going with that drawing. Drop our standard views as we did last time. And you're ready to start cooking. Oh, let's put our views in some funny places. There's one down there. That doesn't make a lot of sense why it's done that. Anyway, I'd expect you to have the tools you need now to start get going on that all by yourself. Rename the sheet, just keep it clean, keep it tidy as you're going, make sure that everything is 100% clear. Thank you very much.